I want to quickly introduce this concept of an exponent, and in particular I want to look at natural and integer exponents. And so what I mean by that is, starting out with natural exponents, and if you need a quick refresher about what natural numbers are, I have a video explaining the different basic categories of numbers. If I have something like this, let's do an example. If I had 2 cubed, the cube here, this is my exponent. And cube, a 3, is a natural number. So this is kind of what I mean by natural exponents. And when I say 2 to the third power, or 2 cubed in this case, all that means is I multiply 2 times itself 3 times. Okay, so if you do that calculation, 2 times 2 times 2, you'll see that 2 cubed is 8. And we can do other examples like this. If I did 3 to the fourth, for example, what does that mean? That means 3 times 3 times 3 times 3, 4 times, which is 3 times 3 is 9, times another 3 is 27, times another 3 you get 81. So natural exponents are very visual. I understand that when I say, hey, I need to know 6 to the fourth power, that just simply means 6 times itself 4 times. So what about integer exponents? So my question now becomes, what happens when I have something like this? I want to do an example of maybe 2 to the negative 3 power. Well, I can't write 2 times itself negative 3 times. Okay, so this actually means something a little bit different intuitively, but they are related. And so here's kind of the idea. Let me give you a property here. If I have a to the n power times a to the m power, I can add those two exponents together. And you can visualize this easily with natural exponents. If I have 2 squared times 2 cubed, notice that means 2 times 2, right, from the 2 squared, times 2 times 2 times 2 for 2 cubed. And now look what I have. I have 2 to the fifth. See, I added their exponents together. But what if I do this? 2 to the 0 times 2 squared. Well, according to my property, that should still be 2 squared, right? Because I add 0 plus 2 as my exponent. Okay, so I still get 2 squared. So what that means then is, as a property, here's our first one. My second one is if I have something to the 0 power, I get 1. I should note that 0 to the 0 power is not defined. Okay, you can't do that. But anything else to the 0 power gives you 1. And so that's actually the first part of my integer exponents here, right? Because 0 is an integer. But what about a negative power? So the negative powers get introduced. So here, think about 2 to the negative 3. If I took 2 to the negative 3 and multiplied it by 2 cubed, well, according to my property 1 here, that should be 2 to the negative 3 plus 3, which is 2 to the 0, which is 1. So in other words, 2 to the negative 3 power canceled out 2 cubed. Okay, so 2 cubed times what gives me 1? Well, 1 over 2 cubed, right? 2 cubed times 1 over 2 cubed gives me 2 cubed divided by 2 cubed, which is 1. So another property I have, and this is what we mean by when I have a negative integer exponent, we'll call it property 3. A to the negative n power means 1 over a to the n, and that's the same thing as saying 1 over a to the n power. And so the negative exponents are actually reciprocals. So for example, if I wanted to know, hey, what's 3 to the negative fourth power? Well, we already know 3 to the fourth power is 81. So 3 to the negative fourth power is 1 over 81. It's the reciprocal of 81. And so this is what we mean by integer exponents and natural exponents. And here we have some really important properties. You can add to this property list. Now, if I divide by exponents, what does that do? Well, division, this is the same as saying a to the n times 1 over a to the m power. 1 over a to the m power means you have a negative m there. So this is a to the n times a to the negative m, and by property 1, that means I'm subtracting. So when you divide your exponent, when you're dividing two things, you subtract the exponents. I hope this makes sense. This is really useful. Understanding how to manipulate these things is really powerful. And we can also talk about rational exponents, but I didn't want to do that yet. I just wanted to get a natural and integer exponents. Please let me know if you have any questions. I'd be glad to help.